Take a moment and look around. Chances are you're surrounded by glass, windows, phone screens, bottles, maybe even the lenses in your glasses. It's so common, so ordinary that we rarely stop to think about it. But here's the strange part. Glass is made from solid materials like sand, yet somehow it lets light pass right through it. That's not normal. Most solid objects, wood, metal, stone, block light. You can't see through them. So why is glass different? Why does something that starts as rough, opaque sand become nearly invisible? Today, we'll uncover, why is glass transparent? The answer lies deep in physics, in the way light interacts with matter at the smallest scale. And once you understand it, you'll never look at a window the same way again. So let's get into it, right here on History of Simple Things. Before we get into glass specifically, we need to understand what transparent actually means. When light hits an object, three things can happen. It can be absorbed, reflected, or transmitted. Absorbed means the material takes in the light and converts it into energy, often heat. Reflected means the light bounces off the surface. This is why you can see your reflection in a mirror. And transmitted means the light passes through the material. A transparent material is one that allows most visible light to pass through without scattering it too much. That's why you can clearly see objects on the other side. But this raises a deeper question. Why do some materials let light pass through while others stop it? To understand this, we need to think about what light really is. Light is a form of energy made up of electromagnetic waves. These waves travel incredibly fast and interact with atoms when they hit a material. Now, here's the key idea. Whether a material is transparent depends on how its atoms respond to these waves. In many materials, the atoms absorb the energy from visible light. When that happens, the light doesn't pass through, it gets stopped. That's why something like wood or metal looks solid and opaque, but glass behaves differently. Glass is made primarily from silicon dioxide, the same basic material found in sand. But when sand is heated to extremely high temperatures and then cooled quickly, something unusual happens. Instead of forming a neat, repeating crystal structure like most solids, glass forms a disordered structure. Scientists sometimes call it an amorphous solid. In a crystal, atoms are arranged in a precise, repeating pattern. In glass, the atoms are more randomly arranged, somewhere between a solid and a liquid. This disordered structure plays a crucial role in its transparency. Here's where things get interesting. The electrons inside atoms can only absorb specific amounts of energy. Think of it like steps on a ladder. You can't stand between steps. You have to land exactly on one. Visible light doesn't have the right amount of energy to excite the electrons in glass. In other words, the electrons don't accept that energy, so they don't absorb the light. Since the light isn't absorbed, it keeps moving forward. At the same time, the structure of glass doesn't scatter light very much. The waves pass through relatively undisturbed, which is why you can see clearly through it. So transparency isn't about being empty. It's about not interacting with light in a way that stops it. Now compare that to something like wood or metal. In metals, electrons move freely. When light hits them, these electrons absorb and re-emit the energy in a way that reflects the light instead of letting it pass through. That's why metals are shiny and opaque. In materials like wood or plastic, the structure is more complex and irregular at a larger scale. This causes light to scatter in many directions, preventing clear transmission. So even if some light passes through, it gets scrambled. That's why these materials look solid or cloudy instead of transparent. Glass, on the other hand, hits a sweet spot. It neither absorbs visible light nor scatters it significantly. Even though glass is transparent, it's not perfectly invisible. If you look closely, especially at thick glass, you might notice a slight tint, often green. That's due to tiny impurities like iron that absorb certain wavelengths of light. Also, when light passes through glass, it slows down slightly and bends. This bending is called refraction, and it's why objects can appear distorted when viewed through curved glass. So while glass is highly transparent, it still interacts with light in subtle ways. Here's another twist. Glass doesn't let all light through. It's transparent to visible light, but it blocks much of ultraviolet, UV, light. That's why sunlight coming through a window doesn't give you a sunburn as quickly as direct sunlight outdoors. This happens because UV light has higher energy than visible light, high enough to excite the electrons in glass. So instead of passing through, it gets absorbed. This selective transparency is actually very useful. It protects us from harmful radiation while still letting us see clearly. Understanding why glass is transparent isn't just an interesting science fact. It has real-world importance. From designing better lenses and screens to developing protective coatings and solar panels, the way materials interact with light is crucial. Even something as simple as choosing the right type of glass for a building can affect energy efficiency, safety, and comfort. So the next time you look through a window, remember, you're witnessing a precise balance of physics that makes modern life possible. Glass is one of those things that feels completely ordinary until you stop and think about it. It's not just transparent, it's quietly extraordinary. And maybe that's the most interesting part of all. The world is full of things we don't question, not because they're simple, but because they're so familiar. Glass is one of them. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us in this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.